So we're going to spend the next couple days working on rational expressions, and specifically we're going to be adding and subtracting rational expressions. So something just to remember is that if it is rational, that means that it is a fraction, so it is fractional. So all we're really doing is adding and subtracting fractions. So just to review what that means, we're going to look at some numbers because it's way easier to work with numbers than it is to work with variables to begin with. So if we have to add 1/5 plus 1/10, well, we need a common denominator. And to get a common denominator, I would need to multiply 5 times 2 so that the denominators would be the same. And if I do that to the bottom, I have to do that to the top. So really this becomes 2/10 plus 1/10, which is going to give me 3/10. So that's one example of a problem we need a common denominator for. Another example would be 1/6 plus 1/9. So we need a common denominator. So our least common multiple of these would be 18. So I would need to multiply 6 times 6 times 3, because a lot of you guys can figure that out, that that's the least common multiple, but I want to show you what that mathematically means. So, because this will help make sense with what we're doing with this lesson. So we have 1/6. Well, 1/6 is 1/2 times 3, and 1/9 is 1/3 times 3. In order for these denominators to be the same, then my factors in my denominator have to be the same on both sides. So if we look at this denominator, which I'm going to highlight green, the green denominator has a 2 and a 3. Well, if we compare it to the other denominator, which I'm going to highlight yellow, the other denominator has a 3 and a 3. So if I need them to be the same, then the denominator on the right needs a 2, and the denominator on the left needs another 3. So this is mathematically how we get our common denominators, is that we need to have those same factors. So then my problem becomes 3/18 plus 2/18, which would be 5/18, and 5/18 would be my answer to that problem. So looking at problem B on page 518, before we get into adding and subtracting, we need to just get into some basic simplification. So if we wanted to simplify this, just like with fractions, we reduce fractions all the time, we need to figure out what this factors into, because my denominators and my numerators are typically going to factor. So x squared plus 5x plus 6, so if I make my t-chart, my product, sum chart, my product needs to be 6, my sum needs to be 5, so that's going to be 2 times 3. So this becomes x plus 2 times x plus 3 divided by, I need to factor my denominator as well, x squared plus 3x plus 2. So I'm going to draw a t-chart for that. My product, sum chart, my product would be 2, my sum would be 3, so my numbers are 2 times 1. So that part of my denominator factors to x plus 2 times x plus 1. And then I still have my x plus 3 there. So I'm going to leave that alone. So applying the ideas of what we've been learning about holes and vertical asymptotes, you can see that there is going to be a hole at -2 because these two cancel, and at -3 because those two are the same. So I'm going to write that down, but I'm going to write it in a different format. I'm going to write x cannot equal -2 and -3. And where this idea comes from, it relates to your domain of our problems. Remember, when we wrote our domain, we said that our domain excluded our holes and our vertical asymptotes. So every single hole and every single vertical asymptote has to be written as x cannot equal. And so we write this slash through there because we're saying that x can't be that. Other than that, x is good, but x cannot be -2 and -3. So also looking at this, we can see there would be a vertical asymptote at -1 because I have this factor in the denominator of x plus 1, and so that would be equal to 0 if x was -1. So these are my 3 excluded values. These are my 3 excluded values, and they are part of the answer. So the rest of our answer comes from looking at our factorization of our problem here and looking to see, like, mathematically, what can we do to this? Well, notice, and we talked about this a second ago, that we have x plus 2 on both the top and the bottom. And in a fraction, when you have the same thing on top and bottom, mathematically they cancel each other out. So those x plus 2's are gone. The same thing is true with our x plus 3's because they're the same on top and bottom, that they also cancel each other out. So really in this problem, I am just left with x minus 1, or sorry, x plus 1 in the denominator. In the numerator, there's nothing there, so we put a 1, because technically, if I do x plus 2 divided by x plus 2, I get 1. X plus 3 divided by x plus 3 is 1. And my final answer to my problem would be 1 divided by x plus 1, where x cannot equal negative 2, negative 3, and negative 1, because these are my excluded values. So part of your assignment is going to be just with this simplifying. So problem 3 on the same page, on page 518, we have x plus x cubed times 1 minus x squared divided by x squared minus x to the 6th. So let's start with x plus x cubed. Let's see if we can factor that. So x plus x cubed, I have an x that I can take out, so I'm left with 1 plus x squared. And then if I look at 1 minus x squared, that also factors. That's a difference of squares, so that becomes 1 plus x times 1 minus x. And then divided by, if I look at my denominator, I have x squared minus x to the 6th. So first of all, that has a greatest common factor of x to the 2nd, so I can factor out an x squared, and I'm left with 1 minus x to the 4th. But this problem can factor some more. The numerator can't factor anymore. I know a lot of you probably want to factor 1 plus x squared, but you can't because there is a plus sign there. But you can factor the denominator some more because 1 minus x to the 4th is again a difference of perfect squares. So my numerator is still the same, x times 1 plus x squared times 1 plus x times 1 minus x divided by x squared, and then 1 minus x to the 4th factors into 1 minus x squared times 1 plus x squared. So it was able to factor again. And amazingly enough, we're still not done because this factors again. And what factors this time is our 1 minus x squared. That factors into 1 minus x times 1 plus x. And then I still have that 1 plus x squared. So now that we have all of this completely factored, we cannot factor it anymore. The only thing we could potentially factor is anything that has x squared in it, and both of these are 1 plus x squared, so they're for sure not going to factor, and hopefully you notice that they're the same. So what we've got to figure out is what's the same on top and bottom, what can we eliminate? So we're looking for things that we can cancel out, things that are the same on top and bottom. And for two reasons. Number one, those things are going to give us our wholes. They're going to give us our excluded values. So let's list those out first. So we have our excluded values, and that's anything where there would be a hole in the graph. So those are x cannot equal. Well, there's going to be a hole at negative 1, because I have 1 plus x and 1 plus x, so those are going to cancel, and I'm going to be left with a hole there at negative 1. There is also going to be a hole at positive 1, because our 1 minus x and 1 minus x are going to cancel. There is not going to be a hole from 1 plus x squared, because if you were to set 1 plus x squared equal to 0, and try and solve that, you would subtract 1 from both sides and you would get x squared equals negative 1. There is no way for that to ever equal negative 1, so that's not going to be a hole or an excluded value for us. And then really all that we're left with is x over x squared, and that's going to reduce. It's not going to cancel, but it is going to reduce, because if I have 1x on top and 2x's on bottom, I'm really just going to be left with the answer 1 over x. And there's also an excluded value at 0, because if I were to set this x squared equal to 0 and solve, I would get x equals 0. So there's going to be an excluded value there. Remember, excluded values are anything that would give you a horizontal asymptote or sorry, vertical asymptote or a hole in the function. So this would be my final answer to the problem. They would have 3 excluded values, -1, +1, and 0, and the function would be 1 over x. So we're going to look next at problem B on page 519. So we have 2x squared divided by x squared minus 5x minus x squared plus 3x minus 4. So we need to we need to simplify this, but in order to simplify this, we need to get a common denominator. And you can go back and you can look at the practice problem that I did to begin with, where we had 1 over 6 plus 1 over 9, and we had to get a common denominator there, because that will be a good thing to reference as we go through this. So in order for us to get a common denominator, we really need to factor our current denominators and see what they actually are equivalent to. So we have 2x squared divided by x squared minus 5x factors, because I can take out an x and I'm left with x minus 5. And then minus, I'm going to leave the numerators alone for now, x squared plus 3x minus 4, divided by, you cannot factor x squared, but for purposes of what we're doing today, I'm going to write it as x times x, because I want you to see what these denominators are currently made of. So if you look at them right now, this denominator has 2 factors. It has an x, and it has an x minus 5. And if you look at the other denominator, it has an x and it has another x. So each denominator has 2 things that are being multiplied, and we need to come up with the lowest common multiple, or the lowest common factor of both of these, least common multiple, sorry, of both of these. And the way that we do that is we just look to see what the denominators are missing. So like if you look at this green denominator here, it has 2 x's. Well, this blue denominator has an x, and then it has an x minus 5. Now notice that this x minus 5 is in parentheses. That means they're all attached together. So this denominator in the right is missing an x minus 5. It doesn't have that. Yes, it has an x, but it doesn't have an x minus 5. Those are different. So that means we need to multiply by x minus 5 on the top and bottom of the fraction on the right. So then if you look to see what else is different, well, you'll notice that the denominator on the right has 2 x's, while our denominator on the left only has 1. So that means the denominator on the left is missing an x. So I'm going to multiply by x on both the top and the bottom. And now my 2 denominators are identical. And once my denominators are identical, we can start simplifying. So the numerator becomes 2x cubed divided by, I'm going to write that as x squared times x minus 5, just to kind of make it prettier, but not go ahead and distribute it out fully, minus, then we have on the right side x squared plus 3x minus 4 times x minus 1. So we have to do a lot of multiplying. We have to distribute. So I did all my distributing, and now we need to combine like terms, because in order for this problem to work out, we've got to do some combinations here. So we know that we can combine negative 5x squared plus 3x squared. That's going to give us negative 2x squared. We can also combine our negative 15x minus 4x, which is going to give us negative 19x. We can't combine our x cubed with anything. We can't combine our plus 20 with anything. So now we're just going to bring everything else down. And I'm at the point now where all I have left to do is combine these 2 fractions together. Well, since this is a subtraction problem, I want you to remember that if you are subtracting, what that really means is that there is a negative 1 here, and you're multiplying that entire numerator by negative 1. So I'm going to rewrite this entire problem. I'm going to leave my denominator alone, but I'm going to go ahead and combine them together. So we have x squared times x minus 5. I have 2x cubed on top, and now I'm going to do some distribution here so I can put all this in one spot. So negative 1 times x cubed is negative x cubed. Negative 1 times negative 2x squared is positive 2x squared. Negative 1 times negative 19x is positive 19x. And negative 1 times positive 20 is negative 20. And if we look at our problem the way it is now, we're looking to see if we can actually combine anything together. And hopefully you notice that we do have some like terms, that we can put our 2x cubed and our minus x cubed together. And 2x cubed minus x cubed is x cubed. So I end up with x cubed plus 2x squared plus 19x minus 20 divided by x squared times x minus 5. And that is as simplified as this problem is going to get. There's nothing else we can do to simplify this problem. But we also need to look for our excluded values, what x cannot equal. Well, I have two factors in the denominator, so I'm going to have two excluded values. So looking at my factors, my first factor is x minus 5, so that means I have an excluded value of positive 5. I also have a factor of x squared, which means that I'm going to have an excluded value of 0. So I have two excluded values in this problem. That means my x's, my domain, cannot include 5 or 0. So I assigned for you to do the odd problem. So your homework assignment is 1 through 2, 5 through 8, 9 through 12 9 through 17 odd problems, and then 23. So I'm going to go through and do some of the even problems on here so that we can have some more practice with our adding and subtracting our rational expressions. So starting with problem 10, as long as we have common denominators, then we're good to go. If we don't have common denominators, that's when we have to do some math. So if you look at your two denominators that you're given in problem 10, notice that both of them are x squared minus 4. So we don't have to do a lot of work on this problem. We can go ahead and start combining stuff together. So I'm going to write this as one big fraction, x plus 4 plus negative 2x minus 2 divided by x squared minus 4. And then we're just looking for our like terms, so we can combine x and negative 2x, which is going to be negative x, and we can combine 4 and minus 2, and 4 minus 2 is 2. My denominator stays the same, so my answer to this problem is x plus 2 times x squared minus 4. The only thing I have left to do is I have to figure out what can x not equal. So in order for it to not equal those things, I have to look at a couple things. I have to look for my wholes and my vertical asymptotes. Essentially, all I really have to figure out, though, honestly, is I got to figure out what's going to make my denominator equal 0. If I were to set x squared minus 4 equal to 0, where would my problems be? Because that's really all that matters. Well, x squared minus 4, I can factor that to x plus 2 times x minus 2 equals 0. And if we have two things that multiplied together to equal 0, then one of those two things must equal 0. So that means for us that either that if we have a problem if x equals negative 2, or we have a problem if x equals positive 2. Just doing the math, I need to subtract 2 from both sides from the left side, and then on the right side I have to add 2 to both sides. So I get x equals negative 2 and x equals positive 2, and those are my excluded values, negative 2 and positive 2, because those are the two times that my domain is going to equal 0. And that's when I have a problem, is when my domain equals 0, or my denominator equals 0. So problem 12. Again, we have common denominators, so this works out pretty nice. Because notice both my denominators are x squared plus 1, so I don't have to find common denominators. So I'm going to go ahead and write it as one giant problem. We have 4x to the 4th plus 4 minus 8 divided by x squared plus 1. And we're looking for like terms. We can combine the plus 4 and the minus 8 together. And 4 minus 8 is negative 4. So we have 4x to the 4th minus 4 divided by x squared plus 1. So we need to figure out if we have any holes, if we have any excluded values from our denominator. So we got to figure out what x cannot equal. In order for that to happen, we need to figure out what makes our denominator equal to 0. So I'm going to set x squared plus 1 equal to 0. Well, mathematically, I would need to subtract 1 from both sides to solve this, and I get x squared equals -1. Hopefully you notice, can't do that because I cannot take the square root of -1. There is no way to multiply something by itself and get -1. So that means that for this problem, there are no excluded values. So my answer is 4x to the fourth minus 4 divided by x squared plus 1, and there are no excluded values this time. So problem 14, we have our first real problem where we don't have the same denominator. So our first denominator is x squared plus 3x minus 4. Our second denominator is x squared minus 3x plus 2. So we're going to go ahead and factor those out. So I have 1 divided by, and I need to figure out if I can factor x squared plus 3x minus 4. So I have -4 and +3. So my factors that multiply to give me -4 and add to 3 are +4 and -1. So this factors to x plus 4 times x minus 1. And then we have minus and 1 divided by, and we've got to factor x squared minus 3x plus 2. So again, make my t-chart. And we have +2 as my product, -3 is my sum, so my numbers would be -1 and -2. So x minus 1 times x minus 2. And now I just need to make sure that I have common denominators. So I'm looking at my factors, at what I currently have. So first of all, they both have x minus 1, so that's good. But this, my green one has an x plus 4, and I don't see an x plus 4 over here with the yellow, so that means I have to multiply the numerator and the denominator by x plus 4. And then my yellow denominator has an x minus 2 that my green one doesn't have, so I have to multiply the top and the bottom of my left fraction by x minus 2. So that gives me a new numerator of x minus 2, because 1 times x is x and 1 times -2 is -2. So x minus 2 divided by, and I'm going to leave all these as factors, x plus 4 times x minus 1 times x minus 2. And then minus 1 times x is x, 1 times 4 is 4, divided by x plus 4 times x minus 1 times x minus 2. It doesn't matter what order you write them in as long as you have all the factors there. So I just wrote them in the same order that these were written in. So at this point, I'm ready to combine these together to give me one fraction. So I'm going to write one division symbol with x plus 4 times x minus 1 times x minus 2 is my denominator. And then in my numerator, I have x minus 2 minus x plus 4. So remember, I'm subtracting this entire quantity. And the problem we looked at earlier, we distributed that -1 out. So let's go ahead and do that, because I think that makes a little bit more sense. So if I'm subtracting this, then really what I'm doing is I'm saying, hey, there's a -1 here, and I need to multiply all these by -1. So that gives me -x minus 4. Well, if we look at this now, we can cancel out some stuff. We can cancel out our x's, because x minus x, those are going to go away. X minus x is 0. And I can combine -2 minus 4, which is -6. So my answer is -6 divided by x plus 4 times x minus 1 times x minus 2. But I have to figure out my excluded values. I have to figure out what x cannot equal. And that's based on each of my factors in the denominator. So my first factor is x plus 4. So if I have x plus 4 as a factor, that means that x cannot be -4. My second factor in my denominator is x minus 1. So that means that x cannot be +1. And my third factor in my denominator is that x minus 2, so that means that x cannot be +2. 2. So my complete answer to this problem is negative 6 divided by x plus 4 times x minus 1 times x minus 2, where x cannot equal negative 4, 1, and 2. Okay, problem 16. So we've got a couple different denominators here, so you can see that. That's not anything surprising. So we have 9x squared minus 4, and we have 3x squared plus 2x. We need to get common denominators. So we're going to leave our numerators alone for now, not worry about those. We have negative 3 divided by, well, 9x squared minus 4, that's a difference of perfect squares. That factors into 3x minus 2 times 3x plus 2. Then plus 1 divided by 3x squared plus 2x factors, because I can take out a GCF of x, and I'm left with 3x plus 2. So now I have to look and see what are the factors that each denominator is missing so that they can be equivalent denominators. So first thing I notice is this denominator has a 3x minus 2 and a 3x plus 2. This denominator only has a 3x plus 2. That means that I have to add in a 3x minus 2 so that those are the same. I'm also noticing that my denominator on the right has 3 factors. My denominator on the left only has 2 because this one doesn't have the x here. So that means that I need to add in an x in the denominator. And if I do that to the denominator, I also have to do that to the numerator. So I need to multiply by x in the numerator on the left. I need to multiply by 3x minus 2 on the right. And then I just need to do some work with my numerators. My denominators are the same, so we're good to go. Now it's just working with my numerators to see what needs to happen here. Well, negative 3 times x, that's just negative 3x divided by x times 3x minus 2 times 3x plus 2 plus 1 times 3x minus 2 is 3x minus 2, because distribute that 1 out, divided by x times 3x minus 2 times 3x plus 2. So I'm ready to go ahead and combine these as one fraction. So I'm going to make one denominator, x times 3x minus 2 times 3x plus 2. And my numerator is now negative 3x plus 3x minus 2. So I'm looking for anything I can combine, anything I can simplify. So just in the numerator, we can see that we have negative 3x plus 3x, and hopefully you think, oh yeah, those cancel. Negative 3x plus 3x, those are going to cancel each other out. So they're gone. And we are just left with negative 2 on top, divided by x times 3x minus 2 times 3x plus 2. So that is my entire numerator and my entire denominator, and I can't do anything else mathematically with that, so that's my answer except for my excluded values, what x cannot equal. So to find my excluded values, I've got to figure out what my factors of my denominator are and what would cause them to equal 0. So we start with the first one, which the first one is x. If x were to equal 0, that would just mean that x could not be 0. That would be a problem because we would get a 0 in our denominator. My second factor is 3x minus 2, so if I set that equal to 0 and solved, I have 3x minus 2 equals 0, so we add 2 to both sides. We get 3x equals 2, divide by 3, divide by 3. So if x was 2/3, we would have a problem. We would have a asymptote or a hole at that point. I think we'd have an asymptote at that point. And then we have 3x plus 2. So if we set that equal to 0, 3x plus 2 equals 0 and solve. Minus 2 from both sides, and we get 3x equals negative 2, divide by 3. And we get x equals negative 2/3, so that means we have a problem at negative 2/3 as well. So this is my complete answer. Negative 2 divided by x times 3x minus 2 times 3x plus 2, but x cannot be 0, 2/3, and negative 2/3. Okay, our last problem that we're going to do is problem 18. So we need to get common denominators. And there's something weird that happens in this problem, and this is why I'm glad that we're doing this one, because I have, you can see that x plus 3 and x minus 3 are different. But we have this weird 3 minus x thing here, which is almost x minus 3, but not quite x minus 3. So what happens is that 3 minus x really factors, and we can do some factoring with it. I can factor out a -1. So if I factor a -1, that means I'm dividing both of these numbers by -1. And 3 divided by -1 is -3. And negative x divided by -1 is positive x. But I don't really like that. I don't like the way that's written. And what I need you to remember is that -3 plus x is the exact same thing as saying x minus 3. That these two are actually equivalent. So what I'm going to do is I'm going to write this denominator as -1 times x minus 3. And if you're not sure, you can do the math and you can verify that if you were to multiply -1 times x, you would get -x, and -1 times -3 is +3. It's the same denominator both times. It's just written differently. But that helps us because now our denominators don't look as terrible as they did before. So we have x minus 3 over x plus 3 minus 1 over x minus 3 plus x plus 2 divided by -1 times x minus 3. And we need to get common denominators here. So I'm going to go ahead, I'm going to put my factors in my denominator in parentheses because I want to remind you that they are grouped together. So if we need them to have the same denominator, notice that thankfully we have some hope here. We have a little bit of help that we have x minus 3 in the first one, or the second one, and we have x minus 3 in the third one. So that for sure means that we need an x minus 3 in the first fraction. So we're going to multiply the bottom by x minus 3, which means we also need to multiply the top by x minus 3. And then if we look at our second denominator, it has an x minus 3, but it's missing the x plus 3 that we see over here. So we have an x plus 3 that's got to show up everywhere. So I'm going to put x plus 3 in the denominator and x plus 3 in the numerator. Same thing with the third fraction. I need x plus 3 in both places. And I know some of you are thinking, oh, and we have this -1 here that we need to do something with. Not going to disagree with that, but we're not going to put that in our denominator because it's actually going to cause us way more work than it has to. And here's why. You've got to think about your sign rules with multiplying and dividing. That if I take something and I divide it by a negative, that's the same thing as taking something negative and dividing it by a positive. Dividing by a -1 only changes the sign. That is it. It doesn't do anything else to the problem but change the sign. So we can take care of this -1 that's in the denominator by doing some really simple math. And that simple math is just changing this plus sign right here to a minus sign. If we change that plus sign to a minus sign, then what that does is it gets rid of our -1 in the denominator. That takes care of our sign change for us. And then I don't have to worry about going through and multiplying everything by -1. I just had to change that sign. If you need some clarification on that, please come by. I'll gladly explain it further, but I promise you that it does the exact same thing. That getting rid of this, changing this to a minus sign here is the same thing as dividing by -1. So now we just get to do the work, and we get to do a little bit of math, which isn't awful. It's not terrible, but it's not great either. So we have on our numerators, we need to fix those. X minus 3 times x minus 3, we're going to FOIL. X times x is x squared. X times -3 is -3x. -3 times x is -3x. -3 times -3 is +9. I'm going to go ahead and just for space sake, I'm going to combine those -3x's together. And -3x minus 3x is really -6x plus 9. divided by, I still have x minus 3 times x plus 3 minus 1 times x plus 3 is going to be negative x, 1 times x plus 3 is just x plus 3 divided by x minus 3 times x plus 3. And then minus, we got to do some foiling over here. We have x times x, which is x squared, x times 3, which is 3x, 2 times x is 2x, 2 times 3 is 6. Again, I'm just going to go ahead and combine my like terms together because my 3x and my 2x can be combined. And 3x plus 2x is really 5x. So this becomes x squared plus 5x plus 6 divided by x minus 3 times x plus 3. So now all my denominators are the same, so that's really nice. And I can go ahead and write this as one fraction with one denominator of x minus 3 times x plus 3. And then put all my numerators together. So we still have the first one, x squared minus 6x plus 9. That's convenient. But here, notice I have a minus sign. Remember we said earlier that's like having a negative 1 that we have to multiply by. So that's going to give us negative x minus 3. Here I also have a negative 1 that I have to multiply by. So that's negative x squared minus 5x minus 6. And yeah, that's long, but there's a lot of stuff that can be simplified, a lot of like terms that can be condensed together. Starting with the x squared, so I have x squared minus x squared, those are going to cancel each other out. Then we have negative 6x minus x minus 5x, that's going to be negative 12x. And we also have the plus 9, the minus 3, and the minus 6. Well, 9 minus 3 minus 6, those are going to cancel too. So I'm just left with negative 12x divided by x plus 3 times x minus 3. So a problem that looked really complicated really didn't turn out all that bad when you look at what the final product is, what the final answer is. So the only thing I have to figure out now is I have to figure out my excluded values. What can x not equal? And remember, those come from the factors of the denominator. So my first factor of my denominator was x plus 3. So if I have x plus 3 in the denominator, then that means that x cannot be negative 3. X cannot be negative 3. Because if x was negative 3, the denominator would be 0. My second factor in the denominator is x minus 3. So same thing, if I had x minus 3, I cannot have positive 3 as a value for x, because then again my denominator would be 0. So that negative 12x divided by x plus 3 times x minus 3 is my, where x cannot be negative 3 and positive 3, is my entire denominator. And that is all that I have for you today. So I've worked through quite a few examples. So I just want to remind you that their homework is due on Thursday. I will be here for tutoring. I'll be here for tutoring this weekend, or this week, so if you need help, please feel free to come by. I will not have tutoring Monday or Tuesday or Wednesday morning because I'm giving the benchmark both days. But other than that, I'll be around.